Hello, everyone. We are on Notes 2.7, which is on transformations of cubic and quartic functions. So now what we're going to do is we're just going to apply what we know about transformations to our new functions that we've learned this unit, including cubic functions, which remember is f of x equals x to the power of 3, and then quartic functions, which is f of x equals x to the power of 4. Okay? So, the first thing I want to do is question number 1. It says use transformations to graph the following cubic function. So f of x equals -2 times 1/3 of x plus 1 cubed plus 4. So the first thing I need to do is identify, well, what's my parent function? Well, I know my parent function is x to the power of 3. Okay, so now let's go ahead and figure out, well, what kinds of transformations are happening here in order to figure out how to graph this out. Now remember, this 1/3 right here has to be factored out. So let's go ahead and factor that out first so that we have f of x in the proper format. So we'll say -2 on the outside, and then we have 1/3 in outside of our new set of brackets inside of here. If I factor out 1/3 of x from x, I get x left over. Now here's the tricky piece. A lot of people will say this is 1/3 when it's not. That's incorrect. Right here, what I'm doing is I'm taking 1 and I'm dividing it by 1/3, which means I'm taking 1 and multiplying it by 3. So I should get 1/3 times x plus 3, close your brackets, plus 4. Now, if I were to distribute this through, would it give me 1/3 x plus 1? Absolutely. So that's what I need to have there, and I should be good to go for that piece right here. Okay, so now the question is, what types of transformations are happening? So I want to do my stretches first. So this -2 right here, the first thing it's going to tell me is that it is a vertical stretch with a scale factor of 2. But because it's negative, I also know that it is going to reflect over the x-axis. Okay, now this 1/3 right here is going to tell me that I have a horizontal stretch, but be careful, it's a scale factor. Remember, we have to do the reciprocal, so it's a scale factor of 3. Okay, and then we have this 3 right here. This 3 is telling us that we're going to the left 3, and then we have sorry about this, this should say plus 4 right here. So we've got plus 4 right here. This 4 is telling us that we are going up 4. Okay, so now that I've done all that, I've identified what my transformations are. I need to write out my chart for my parent function. Well, if my parent function is cubic, then I'm going to use my cubic values. And yes, these are values you are going to need to have committed to memory. Okay, so I'm going to go from -2 all the way to +2. So -2 when I cube it gives me -8. -1 when I cube it gives me -1. 0 gives me 0, 1 gives me 1, and 2 cubed gives me 8. Okay, so now remember, when we do our transformations, we want to do our stretches first. So the first transformation that we have here are going to be our stretches. So when I do my stretches, what we're going to do is we are going to, this is a vertical stretch of 2. This says multiply the y values by -2. So I'm going to multiply y by -2. And then this right here is telling me if I have a horizontal stretch with a scale factor of 3, this is telling me that I have to multiply x by 3. So let's go ahead and figure out what our new values are here. So I'm going to say x is here and y is here. So if I multiply all the y values by -2, this -8 becomes 16. This -1 becomes 2. 0 stays 0. 1 becomes -2, and then 8 becomes -16. Okay? But I also have to multiply my x values by 3. So this -2 becomes -6. This -1 becomes -3. 0 stays 0. 1 becomes 3, and 2 becomes 6. Okay, now that I've done that, the next thing I need to do is do my my shifts. Okay, and what kind of shifts are happening? Well, I'm going to the left 3, so that means I need to subtract 3 from x, right? And it means that I also have to, if we're going up 4, we're going to add 4 to y. And that's going to bring me exactly where I need to be. It's going to bring me right to my f of x values right here. Okay, so let's go ahead and do that. So every time I see an x, I'm going to subtract 3 from that value. So this -6 becomes -9, -3 becomes -6, 0 becomes -3, 3 minus 3 is 0, and 6 minus 3 is 3. Okay, and then for my y values, it says add 4 to y. So the 16 becomes a 20. The 2 right here becomes a 6. The 0 becomes a 4. The -2 becomes a 2. And the -16 becomes a -12. Okay, so let's go ahead and graph out our information. So let's go ahead and graph out the parent function, because I want to see the difference between the parent function and the transformed function. So right here, my first point is -2, -8. So I'm going to go to -2, -8, and put plot a point there. Then I have -1, -1. Then I have 0, 0. And then I have 1, 1. And then I have 2, 8. And this right here is my parent cubic function. Okay? Now, remember, if it was reflected in the x-axis, the end behaviors are going to switch. So here, since this is approaching -infinity, this is going to come off from positive infinity. So let's go ahead and graph out our transformed function. So -9 will start at 20. Okay, -6 will start at 6. -3 will go to 4. 0 will go to 2. And then 3 will go to -12. And then I'm going to connect my values, my points that I have here. And this is going to be my new function. Okay, so let's see if this really makes sense. Does it seem like the graph was stretched vertically? Absolutely, right? It's the difference between my 5 points is clearly much larger than it is between my 5 points here. Was it reflected in the x-axis? Yep. Was it stretched horizontally? For sure. Did it move to the left? 3? Definitely. Did it move up 4? For sure. And that's how we do our cubic function transformations. Okay? So in question number 2, it says use transformations to graph the following quartic function. So in order to be able to do that, I need to identify what my parent function is going to be. Well, if this is 1/2 x plus 6 to the power of 4 minus 7, then my parent function is x to the power of 4. Okay, so let's identify what our transformations are. So first thing we're going to want to look at is our stretches. Luckily, our coefficient here is 1, so we don't have to factor anything out here. So we can go straight to our stretches, and we can say that it's a vertical stretch with the scale factor of 1/2. Now, technically, it's a compression because it's getting smushed down towards the x-axis. But if I'm going to say the scale factor is 1/2, I have to call it a stretch. If I want to use the word compression, then I would say that it is a compression with a scale factor of 2. I'm keeping it 1/2 so I know to multiply by 1/2. Okay? Now that I've done that, I need to identify, well, what are my shifts? Well, this plus 6 is telling me that I need to move to the left 6. Okay, let me just underline this one in purple so we know what goes with what. And then this minus 7 here is telling me that I need to go down 7. Okay, so let's go ahead and create our parent function chart. And again, this is another chart that you're going to want to memorize. And let's go from -2 all the way to +2. So if I take -2 and I raise it to the power of 4, I get 16. If I take -1, raise it to the power of 4, I get 1. 0 to the power of 4 is 0, 1 to the 4th power is 1, 2 to the 4th power is 16. Okay, so now let's go ahead and start by doing our stretches. In our stretches, we only have 1, and that is a vertical stretch of 1/2. So that means that since it's vertical, I need to multiply my y values by 1/2. So let's go ahead and figure out what my new graph will look like right here. So my x values are going to stay the same. but my y values are going to be half as big. So 16 becomes 8, 1 becomes a half, 0 stays 0, 1 becomes a half just like before, and 16 is also going to be 8 right here. Okay, and then the next thing I need to do is are my shifts. So let's go ahead and figure out what our shifts are going to look like. So right here in my shifts, I've got x here, I've got y here, and I'm going to have 5 points again, but this time it's going to bring me to my final answer. So I'm going to call this f of x right here. And if it went left 6, that means that I have to subtract 6 from x. And then if it went down, I forgot to write down how much it went down by. If it went down by 7, I'm going to subtract 7 from y. Okay, so let's figure out what these values here are going to be. Well, when I subtract 6 from x, this negative 2 should become negative 8. When I subtract 6 from negative 1, I get negative 7. This gives me negative 6, negative 5, and negative 4. Okay, when I subtract 7 from y, 8 minus 7 will give me 1. 1/2 minus 7 will give me negative 6.5. Negative 6 minus 7 gives me negative 7. Sorry about that. And then this will be negative 6.5, and this will give me 1. So let's go ahead and set up our graph. I want to graph out the original, the parent function, and the f of x function. So since my x values range from negative 8 is my smallest x value for both of them, all the way to 2 for my largest value of x for both of them, I'm going to go up by 1s again for my x values. Okay, sorry, I don't know why it keeps shifting down. So we'll put 0, 5, 10 here, 10 here, 5 here, okay, and then we know that our y values are going to go anywhere between 0 and 16 here, and negative 7 and 1 here. So we want to go from negative 7 to 16. I think going by 2s are going to be our best bet right here. So I apologize for this. I don't know why I put 10 and 5. Let's put 10 and 20. So we'll put 10 here, and then we will put 20 here. Okay. And then we'll put negative 10 right here and negative 20 right here. So now that I've done that, I can go ahead and graph out my parent function. So negative 2 will correspond with 16. Negative 1 goes to 1, 0 goes to 0, 1 goes to 1, and 2 goes to 16. So right here, I have my Quartic function. Okay, now let's go ahead and graph out what our f of x is going to be. Well, f of x is going to be these values right here. So I go to negative 8, 1 right here. So negative 8 will correspond with 1. And then I have negative 7 is going to go to negative 6.5. So right here is negative 6. Negative 6.5 is about a quarter of the way down. Excuse me, and then negative 6 will go to negative 7, negative 5 will go to negative 6.5, and negative 4 will go to 1. And then this is what my transformed graph should look like. Okay, so this right here is my f of x. And these transformations definitely look like they have happened to this graph right here. So we are done with this lesson. See you next class.